Lesson 6.2, using equations to set up and solve multiplication and division problems. The directions ask us to solve each problem and draw a model if you need to. Number 1, during a rock climbing competition, competitors raced up identical sections of a wall. Altogether, there were 568 handholds in the 8 identical sections. How many handholds were in each section? Okay, and so for this, you can kind of visualize a gym with a huge rock climbing wall, and it's been kind of organized into these 8 identical sections, and each of these sections has these little handholds, right? We are told how many handholds there are altogether. We're told how many sections there are, and we're asked to solve for how many handholds in each section. So I'm going to use variable s to represent the unknown, and I'm thinking division. The total number of handholds divided by the number of sections. Over here, I'm going to set this up as long division. How many times does the 8 go into 56? 7 times. 8 times 7 is 56. Bring down the 8. How many times does 8 go into 8? 1 time. Multiply that out. Subtract. Nothing left to bring down. Nothing left over. Each of these sections had 71 handholds. Number 2, for every quarter turn of a crank, a gear rotates 1 time. How many times did the gear rotate if the crank is turned 8 times? Okay, so imagine a crank that you turn and it activates or allows a gear to rotate. A quarter turn gets me 1 rotation. All right. Half of a turn gets me 2 rotations. 3/4 of a turn gets me 3 rotations. And a full turn, or 4/4 of a turn, gets me 4 rotations. So 1 turn, 1 complete turn, gets me 4 rotations. Now, how many times did the gear rotate if the crank is turned 8 times? All right, well, if the crank is turned 1 time, we get 4 rotations. So I'm thinking, for how many times did the gear rotate? Maybe G for gear equals 4 times 8. 32. Number 3, the area of a television screen is 161 square inches, and one measure of the screen is 11 5/10 inches. What is the other measure of the screen? Okay, so here, of course, we are dealing with a rectangle, and it's a problem involving area. We know the area. The area is 161 square inches. And we know the measurement of one side. Let's say it's this side. It's 11 5/10. So the area is equal to the 2 dimensions multiplied by each other, length multiplied by width. In this case, let's say that we're given the width and we're trying to determine the length. Well, look at my equation. How do I isolate only the length? I've got to somehow get rid of the times W. And the way to get rid of the times W is to divide both sides by W. A divided by W equals L. So the length is equal to 161 divided by 11 5/10. Set this up as long division here. Gonna have to write small. Okay, 11 and 5/10 goes into 1. No, goes into 16. Yes. Oh, pause. I've got to clear out my decimal point, don't I? Whoop. Whoop. Let's rewrite this. My new whole number divisor is 115. And my dividend, I add a 0 because I did one push to this side and had to do one push to this side. Now 115 goes into 161 one time. Multiply that out. Let's subtract. The 1's got to borrow. 11 minus 5 is 6. 5 minus 1 is 4. Let's do our bring down. About how many times does 115 go into 460? Well, if you said 4 times, you would have been exactly right. 115 times 4 is exactly 460, and that cancels out. Nothing to bring down, nothing left over. We've got our answer, 14 inches. It's a small TV. Moving on, number 4, each recipe for lasagna requires half a pound of ricotta cheese. How many recipes of lasagna can be made at a restaurant that has 6 pounds of ricotta, assuming all other ingredients are present? Okay. So it's like I'm looking at my overall, I'm going to draw a visual here. Let's say I've got this, this bar that represents my 6 pounds, and divide that up into pounds. 6 pounds of ricotta, and I only need half of a pound to make one serving, I guess you could say, or one tray of lasagna. How many recipes of lasagna can I make if I have 6 pounds? Well, how many times does a half go into 6? Or what's 6 divided by a half? I'm going to use L for lasagna. 6 divided by a half. Now, you might know that as mental math, but think back to when we worked with multiplying and dividing fractions. I can write the whole number 6 as itself over 1. Now, is this looking familiar? When I have a division expression using fractions, I leave what's on the left the same, I change the symbol to multiplication, and I flip what's on the right. And now I think you see where this is heading. I get 12 as my answer. Number 5, a wall that measures 10 feet by 8 feet needs to be painted in Devin's room. The room has 4 such identical walls. In other words, all 4 walls have these measurements. What is the area of the walls in the room that will not be painted? Okay. Let's visualize this. You've got a wall. Let's say that it's 10 feet by 8 feet. And you've got 4 of these. 4 walls. What's the area of the walls in the room that will not be painted? I'm kind of stuck on this one, guys. Let's come back to it in a minute. Number 6, a jeweler is making necklaces that require 50 beads. Altogether, the 50 beads weigh 1/4 gram. Okay. In grams, what's the weight of each bead? Let's use B to represent that. Well, that would be the total weight divided by how many beads we're talking about here. 50. And so let's rewrite 50 as 50 over 1. Now let's change the division to a multiplication, and we get our final answer of 1/200 of a gram. Now, 1 gram equals 100 centigrams. In centigrams, what is the weight of each bead? Okay, well, the weight of each bead in grams is 1/200th of a gram. 1 gram is 100 centigrams. So I got 1/200 times 100. And now let's call this C. Okay, 1/200 times 100/1. Let's multiply the top. Let's multiply the bottom. And let's simplify our answer. 1 gram equals 100 centigrams. I think half. Now, back to number 5. I'm going to give this a few more seconds to mull this over before giving up. I'm picturing the room that needs to be painted. It's got 4 walls, and they're all having the identical measurements. The question is, what is the area of the walls in the room that will not be painted? Oh, now I get it. Only one of the 4 walls needs to be painted. So the area of the wall that needs to be painted is 10 times 8, 80 square feet. But then you got 3 other walls that also have an area of 80 square feet that don't need to be painted. Boy, the wording of that really threw me. 80 times 3, of course, is going to be 240 square feet. I'm glad that I didn't have to give up on that one.